So imagine you have started a new application, like an awesome voting app where you can vote tabs versus spaces, CloudFormation versus Terraform or so. And you create a Docker image and everything works quite nice locally. Now you have to find a way to deploy it to production. And of course you do infrastructure as code, and you start with the CloudFormation template. So what resources do you actually need? Yeah, it's an ACS service. I need that one and a task definition. So let me copy that from my last project, right? And yeah, then how does it work with the scaling again? Let's check the AWS docs. Okay, I need some resources for CloudWatch, which triggers then some scaling actions. And I almost forgot the monitoring, right? So which metric should I check again? Maybe the guys from Cloud. I have a good example, so let's look at that and add it as well. Next, I need a load balancer because it needs to be reached from the outside my application. So add that as well. And then also IAM, roles, permissions, policies. And at the end, for your simple application, your infrastructure contains a couple of hundred lines of YAML code. Does it sound familiar? So ECS is here just an example. We could do that also with EC2, RDS, or Lambda-based setups. So my name is Philipp Garbe. I work at Scout24 as lead platform engineer, where I'm a team responsible for the whole delivery or continuous delivery stuff, from source code control actually into production. And we came up with that topic a while ago, where we felt also some pain working with CloudFormation, that we felt we do always the same things again and again. And that's how we came also in contact with CDK. So I want to give you an introduction to CDK, and maybe first, what is infrastructure as code? Maybe raise your hands, who is doing infrastructure as code? Oh, almost all. And who is using CloudFormation? Okay, maybe then some of these pain points and limitations that I will tell you are maybe familiar to you. I will then also introduce the CDK and then show you how it helps you to boost your infrastructure. Here I want to quote Keith Morris, who also wrote a book about that, of the definition of infrastructure as code. So he said the enabling idea of infrastructure as code is that the systems and devices which are used to run software can be treated as if they themselves are software. So you have to, if you think about that stuff that runs our software should be treated also as software. When you think about your EC2 instance, for example, a load balancer, as a software, it has an API, you can easily create new instances, you can remove them, you can change properties and so on. Why is that so interesting, or why is it that important? For me, the most important thing is that you can automate things. You don't have to click around in your UI and maybe remember all the things that you did, but you just define what you want, and that makes it then also repeatable. So you can have multiple stacks from the same definition. So you can have your own stack, for example. You can have a stack for your production account, and so on. So the same code creates also the same infrastructure at the end. And if you have the infrastructure as a code, you can also put it in your favorite version control system. And then you have all the advantages that you have, or that you are used with your code as well. Like you can look up the history, you can see a diff, or you can blame others. And here are two different styles how you can do infrastructure as code. One is maybe the most common one is the declarative part, where it's more about the what. So you define what you want. So the entry barrier is quite low. It's most likely some text file like a YAML or JSON that you can more or less easily read. But it has also then some limitations, like you cannot do more advanced constructs like loopings or inheritance and so on. On the other side, the imperative way is more about how you achieve that. It's normally done by using one of these higher level programming languages, where you can also use the benefits of these languages. Like I said, loops that can easily be used, or inheritance. In CloudFormation, or when you look at CloudFormation, both ways are actually supported at the moment. So we have on the declarative side, you have already your basic YAML or JSON file. You can also make more advanced stuff there already. So you can use include statements, which means you refer to a snippet which is somewhere stored on an S3 bucket and include that to your template file. And there's also the SAM transformation, which is an opinionated way to define serverless resources, especially serverless resources, where you have to write less of these code. And you can also have your own transformation when you look at macros, where you can write your own logic, and you put then your infrastructure code there, and it will be transformed to a bigger one, actually, or more advanced one. On the imperative side, there are already some tools out there for different languages. For example, with Python, there is Troposphere, Sparkle Formation for Ruby, and GoFormation for Go. But the interesting point here is all these tools work on the client side. So they generate, at the end, always a YAML file, which is then sent to the CloudFormation API. I think that's the interesting point here. And also the difference to Terraform. So, but what are here the problems or limitations of CloudFormation? I would put them in these three categories, like time, security, and trust, and I give you some examples now. Once we have seen in the beginning, it can become very complex. Like for a single job, you have a couple of hundreds of lines of YAML code, and these, like every other code, it needs to be maintained at some point. It can be outdated, or you can have better ways to achieve the same thing. And refactoring here is quite difficult or almost impossible. The next thing that I've seen when working with colleagues or talking to other people or other developers is how do they use CloudFormation? How do they work when they start a new project? And some of them just start from scratch with an empty file, and others use some existing templates and then modify them. At some point, they come to the situation where they copy snippets from different places and fill it up. So maybe might think copy-paste, that's quite smart because it's fast, but actually it isn't, because it costs you time. So the stuff that you copy and paste, you have to search for it, you have to review it, and maybe also adapt to your actual needs. And here comes the next issue as well, because the problem comes, where do you copy from these snippets? Where do you get that? So it's here not so much about malicious code, although that can happen if you think about a Lambda function where you get a zip file from an S3 bucket that's maybe not owned by you, then you don't know what you really execute at the end. But here it's more about where you can copy these snippets from. And people have different levels of trust. So they trust maybe the team more than the company and more than the internet. But also you never know, is the snippet really complete? Like if you look at CloudWatch alarms, it can be very tricky to make them right. Like a small typo or a misconfiguration can lead to the situation that the alarm is never triggered, but it's not very obvious when you look at that. And think about if you copied a snippet from another repository. Now you find a critical problem with, for example, IAM permissions, which are maybe too open. Then do you apply these changes also in the repo where you copied from? Or the other way around? So the repo owner where you copied from made some updates and made some changes, improvements. But how do you know? Also, the owner doesn't know that you copied from him. And it's also very hard to align on best practices, especially within a company or a bigger company or with different team or multiple teams, where you have, it's hard to find a way to share these findings that you get from production and these tweaks that you just learn when your software runs in production, that you can share that easily with other teams and so on. So you can look up, for example, in the IAM or in the AWS docs, but it's more a reference. It tells you what you can do, but it doesn't tell you what is really a best practice. So what is the CDK now? CDK stands for Cloud Development Kit and is one of these imperative approaches to write infrastructure as code. The interesting part here is that it supports already different languages out of the box and on the same level. Like you can write or use CDK when you write in JavaScript, TypeScript, Java, .NET, and Python, and more languages are also coming. It's currently in a public beta, so you can try it out already and work with it. It's also, you can also look up the source code. It's on GitHub. And you can also contribute or open issues there. They're quite active. How does CDK itself look like? So you have 3 different objects in CDK. The first thing is an app, which is the executable program which is then used to render and deploy your CloudFormation templates. We'll see that then later in detail, but normally you don't have to deal so much with an app. An app can contain one or more stacks, and these are then the deployable units. So a stack in CDK is the same like you know a stack in your CloudFormation console. And you have some environment information like which account should it be deployed and also which region. And finally, a stack can contain or should contain at least one or can have more than one constructs, which are then a representation of AWS resources. And constructs can form a hierarchical tree structure. And we see then in a second how that looks like. When you look at the flow, you have on the left side your application, you have your stacks and your constructs, and you get the CDK CLI, which acts kind of as a compiler. And it can synthesize then this template. And this template is just a normal CloudFormation template with the YAML syntax. But the longer you work with CDK, it becomes more like an assembly language. Of course, you can look into it, but you don't do that anymore because it's not interesting. You can also deploy it directly to CloudFormation. So when you look at the construct, there are 3 levels, or the concept of 3 levels of constructs. The level 1 is the CloudFormation resource 1. So this is a one-to-one mapping of the existing resources that you already know from CloudFormation. They are also auto-generated based on the AWS resource types reference. And ideally, you don't have to deal with these level 1 constructs at all. Because there's also level 2. And here it's more on the service level. For example, ECS, S3, Lambda, and so on that level. And they are opinionated, they are handwritten, mostly by the CDK team, but also by the community, and they follow the well-architected framework. And level 3 is then actually what you can do, your awesome stuff, which acts then often on top of them. So you can, for example, create production-ready services. Typical example is, if you think about alarms, if you deploy in Lambda, you have often the same alarms that you're interested in. So you can combine these things in one construct and just use that construct again and again. Or, I had an example which are the CloudWatch logs within a Lambda to define also retention time. But in the meantime, this has been done by the CDK team. It's no part of these level 2 constructs. You can also build reusable solutions like that. Some good examples. One is a tweet queue, which is a library or construct library which allows you to get a feed of Twitter search results and based on a keyword, and it puts it in an SQS queue. So the only parameters that you have with this construct is like an API key for Twitter and the hashtag, and that's it. Or for example, you can have a table view for DynamoDB as a construct which builds like a whole mini application where you can see the content of your DynamoDB. So you can see that's a components and construct which are on a higher level, which then can maybe also can be reused by others. But let's have a look at the code. Let's see if that works. So this is just for the demo. So we create a Docker-based application. Like we can have a look here. We have a Docker file, it's a Python application with a very simple hello world example. And we have here our CDK application. So you see here the application and stack. And now we add resources to the other constructs to that stack. In that case, it's a VPC. So this is normally, you don't do that because not in every application you create your own VPC, but just for the demo. And you will see that this is already deployed because it takes a while to set up the VPC. Okay, so what we can do here is with the CDK deploy command, we can deploy that application directly, and what you can also do is you can also look at it. How would the CloudFormation look like? And it creates a very, very long CloudFormation template just by that single line for the VPC. So what we can do is that we want to have this application. So what you would normally do is you do a lookup from an existing VPC, you create an ECS cluster, and here we have a load balanced Fargate service. Let's just add the import statements. So we can now do a diff, which tells you already a lot of things that it will change. One is the IAM permissions, security group changes, and here we see the parameters that you have and also all the resources that will be created. We just start the deployment. And then we can go a bit into detail. So here it asks again, I think that's an interesting part, because you do critical changes. You change IAM permissions, you change security groups, so you have to confirm that. And we can see also that, as maybe you noticed, we did not define anything about IAM permissions here. These IAM permissions are automatically generated for you, and they follow also the least privilege principle. So only the permissions that are really needed will be created. Of course, not everything will work. Like if you have a Lambda and you access a Dynamo database, it doesn't know that the Lambda code needs access to the Dynamo table. But like here where we said we want to have a load balance Fargate service, we also tell the container image where it should come from, and then it knows what needs to be done. It knows that it needs to create the load balancer, it needs to create the ECS or the Fargate service. It also automatically creates the ECR repository for our Docker image. And maybe you have seen that already. It compiles our Docker image. It pushes the changes to the Docker image to the ECR repository and create then the application. So this is also nice benefit of the CDK CLI. Like for me, it's a missing feature of the AWS CLI that when you deploy on CloudFormation Stack, that you also see the outputs directly in the console, so that you don't have to switch to the UI. So if we go to a second. Should enable to see that, so the update is in progress. Can here also see all the resources that are created. It's like a normal CloudFormation stack. So CloudFormation itself doesn't know that it has been created by the CDK. And after a minute or so, can hopefully then also see that it actually works. Are there any questions so far? To the API, yes. Exactly. But this is kind of transparent to you. As I said, you can do the synth and you can look at these YAML code, but you will never do that. You're not that, maybe if you looking for a problem or so. But in general, just would do a CDK deploy and deploy it directly. How do output formats? Yeah, that's a good question. I don't know. I also suppose that they are not very interested in doing that, especially as they have to focus on as we see maybe also a bit later, in making that stable enough so that. Like that's one of the issues right now is they do a lot, and you have frequent releases, but also with some breaking changes in there. So that's also why it makes not so much sense to use it right now in a bigger area. Not because it's risky, in my opinion, because it's just CloudFormation's template, but more in the sense that you have to. If you update to the latest releases, that you have to apply or to fix all these breaking changes. Yes? I'm not sure. Yeah, I didn't dig so much into that topic, but maybe you can also solve your maybe can solve it also differently, because you in a CDK application you can have also multiple stacks, where you then also define or can say in which accounts they should be deployed, or also in multiple regions. And
I guess multiple regions is no problem, but multiple accounts, I need other roles, other positions.
I think then it becomes more interesting. I'm not sure. Maybe there are some open issues also on the repository itself. Okay, finally it's done. Can just prove it. Yes.
Which level do you provide some parameters? Because when you deploy CloudFormation, you can define parameters like
Yeah.
stack, whatever. You can deploy CDK.
That's yeah. It wasn't planned to talk about that in detail, but you have the context or the concept of context. Like you can, let me show you, which is quite interesting. So all the parameters, and there was also an interesting idea behind that. For example, if you use the AMI from an from an SSM parameter or so, you never know which version you actually or often use. So this is then stored in this context file, which then also allows you to update that context file with the latest version, for example, of these AMI ID, and then have that also under version control. And also here you can then provide additional parameters. Like, I think we have seen them. They are already. I think it was with the div. Okay, now the div doesn't show anything anymore. But there are already in this stack. There are already some parameters. I think we should have seen that here, which are now filled also with some default values, or the values from the context. So it's still supported. Okay, the application is up and running. We can do as well, just to see a bit the possibilities. Here's how you set up auto-scaling for your service, which is which I think is more readable than, so if you compare that to the CloudFormation code. You can also see the diff again. And also if you look at alarms, wait a second, too much. For example, failed request count of the load balancer. So the construct itself give you already some methods back which follows these metric and so on convention. So you can get that as an object, and you see on compile time if that is a correct name for your CloudWatch alarms, for example. Okay. So, and how can you boost that? So, what we have, not seen, but what we have with these level 2 constructs, which you get out of the box already with CDK, is that you have a lot of standard use cases already done, like these load balanced Fargate service, or the example that I showed before, the log retention for CloudWatch logs for Lambdas. Normally, if you create them, they are stored for forever. But here you have the option to define the days, the retention days. Also, the asset handling, Docker images is an example, but you can also store some assets on S3 or so. Helps you already a lot. They are looking at all these options, as you can configure basically everything, but normally the parameters have a very sane default that can already be used, so you don't have to override so much normally. And like in most, all these IAM permissions are also included as long as can detect the relationship between these resources. Like now we didn't do anything regarding IAM and it will still work. Here's an interesting approach which has been merged quite recently. This is also a construct it's the custom resource construct actually. So sometimes you run into the situation that some parts are missing in CloudFormation. CloudFormation doesn't cover that for you. And you have either the chance to write your own custom resource, whatever, and a lot of things to make it possible, or do you have to wait until it will be supported? But this is a quite nice approach to fix that. And this is the example of Fargate, which cannot be triggered by CloudWatch events. So ECS tasks can be triggered, but not Fargate. At least not in CloudFormation. If you do set it up by the CLI, it works. And what you do is you adjust on these construct, which just internally calls then the AWS CLI, and you just define which actions should be called and which parameters does it get, and that's it. So you can easily add this missing functionality with a couple of lines of code. And where I see then the most benefit is when you share your own level 3 constructs. This is not yet there, I think, but I hope that is coming. Because you can build your own constructs and share them as CDK library. And you can use existing technologies, existing package manager, because that's what the CDK team is doing as well. So they provide that as NPM packages for JavaScript, TypeScript, or as Maven for Java and so on, or as .NET packages. And you can do that as well. And you can then you can also benefit from that. So you can share that within your company. You can find patterns. Where do we do always the same again and again? Or maybe you have some compliance rules which needs to be fulfilled, like a secured S3 bucket which follows some internal policies and so on. So you can put these best practices, you can put that in code, not just telling people to write some documentation about that. So we talked here a bit about time, security, and trust, and you know then, here you know who published it, like in any other library. There are also downsides. I think there were some bad problems recently also in the NPM world. But at least you can do that also internally. You set up your own package repository and share that internally within your company. And the good thing is you don't have to reinvent the wheel again and again and again, but you can align on these best practices within your company, just write them as code and share them. And what package managers are good with are updates. So once we have a problem and you have to roll it out, you can easily do that with these package managers, and like dependency management becomes more and more prominent. I think the recent announcement from GitHub that they, I'm not sure if they bought Dependabot, but have an agreement with Dependabot, which sends you pull requests automatically for your dependencies which needs to be updated makes these things quite easy. Compare that to your copy-paste snippets from before. So CDK is an imperative approach. You can write that in any of your favorite, or almost, of your favorite programming languages. I think that's a huge benefit because you're used to that languages anyways. So you don't have to learn anything new. I've seen that this can save you some time. You can easily align on these best practices already with these level 2 constructs. They are really a big benefit compared to now, but you can also go away, or go a step further and write your own constructs. And it keeps you secure with these already these update mechanisms that are already proven. Yes?
As I already said, the meeting point is actually the CloudFormation. So level 2 construct written in Python won't be usable for someone who decided to write it in Java.
Yeah, the way how the CDK team solves that is they write everything in TypeScript and compiles it in the different languages. Like there's another project called GC or GSII, which can compile these TypeScript code into Java, into .NET, into Python, and so on. It's a bit tricky at the moment, so I wrote a blog post about how you can do that by yourself. So it's not well documented. You have to find out all these things by yourself, but I hope that this will be better than once they reach in version 1. But you can actually do the same. So the tools are already there. And if you want to share that, for example, within your company and you want to make it available in different languages, then you have, the downside is that you have to use TypeScript in that case, but you can do that. It's just a compile step and a publishing step into these different package repositories. Yeah, what I said already, it's still beta. There are breaking changes, and not all these, not every AWS service is covered by these level 2 constructs. As there are often also a lot of discussions, what makes sense, what doesn't make sense, and so on. But I think especially in the container and serverless area, a lot of things are already covered. What's not that clear yet is the migration path. So if you have a CloudFormation stack, which you maybe cannot change easily because you have some state there, I think then it becomes interesting, because what the CDK does is it changes the logical resource names as well. So they have the ones that you define also name still, but it gets a hash at the end in addition. And you can fix that with the mapping, but it's not that clear and also not well documented how you can migrate existing CloudFormation templates there. Also, existing limits still apply, like these 200 resource limits per stack, which becomes not that obvious anymore. So like if you have this YAML file at some point, you will maybe notice that there are a lot of resources in that file, but here with maybe some loops or so, it's not that obvious anymore. And I've just said with the language support, if you want to write for different languages, you have to use TypeScript. Not sure if that changed maybe, but at the moment it is like that. Yeah, and there's some more interesting part here is also unit testing. All these constructs are very well tested, and often when I looked up something which I didn't understand how to use it, I looked into the tests, and that makes it easy, and you see how it should be used. They have also some frameworks where it's really easy to write tests for your own construct, especially if you want to share them. It makes sense to define, or just to put your intention why you did things like you did in your tests and verify that. Also the asset handling, we didn't go into detail also with the context, and also it would be a completely separate talk to see how you can do that and deploy that in multiple languages. But if you want to get your hands dirty, I can recommend the cdkworkshop.com page, which is quite nice. You can do that step by step, and it explains also things what is happening there. And yeah, apart from that, if you're interested also in further AWS topics, I'm also part of the community day, which we are preparing for 9th of September in Hamburg. So we'll hopefully hear about that more details what is planned, but save the date already. So, are there any other questions? Yes?
Are nested stacks possible or come with public resources?
Another good question. Nested stacks in that case is not, I haven't seen that in CDK itself, but you can define multiple stacks inside your CDK application. They will not show up as nested stacks, but as separate stacks. Okay, thank you.